chemical bond, intermolecular forces. The definition of intermolecular forces is forces between molecules. The purpose is intermolecular forces allow different particles to be attracted to each other to form solids and liquids. There are three types of intermolecular forces: dipole-dipole forces, hydrogen bonds, and dispersion forces. So what are dipole-dipole forces? They are permanent forces on a polar molecule that causes the weak attraction between polar molecules. In other words, this is the attraction between the positive end of the first molecule to the negative end of the second molecule. These dipole-dipole forces make it harder to separate the molecules. As a result, polar molecules generally have a higher boiling and melting point than nonpolar molecules of similar size. Note that if the molecule is symmetrical, there is no dipole moment. For example, the diatomic hydrogen, which is shown here as H-H, is symmetrical. So therefore, it is not a polar bond, but instead a nonpolar bond. So therefore, there is no dipole-dipole moment. In another example, CH4, as shown here, also do not have is asymmetrical and therefore do not have a dipole-dipole forces. There's a special type of extra strong kind of dipole-dipole forces known as hydrogen bond. This only occurred between hydrogen and one of the following: oxygen, nitrogen, and fluorine. So even though you may see hydrogen bonding with other elements, that is not a hydrogen bond. For example, water, H2O. We have here hydrogen bonding with oxygen, and oxygen is one of the elements listed as the three elements that will bond with hydrogen to form hydrogen bond. In the next example, HF, we have hydrogen bonding with fluorine, and again we have fluorine, which is one of the elements that's on the three element list. In another example, we have NH3, and in H3 we have nitrogen forming a bond with hydrogen, and again nitrogen is one of the three elements. In HCl, we have hydrogen bonded with chlorine. Chlorine is not one of these three elements, so therefore HCl is not hydrogen bonding. Okay. And finally, we have CH4. Here we have carbon bonding with hydrogen. Again, carbon is not one of these three elements, so therefore carbon cannot be hydrogen bond either. Hydrogen bond is the strongest of the three intermolecular forces. The substance with hydrogen bonding increases the melting and boiling point. So water therefore has a higher boiling point than HCl. Substances with hydrogen bonds tend to have much higher melting and boiling point than those without hydrogen bonds. Dispersive forces. Dispersive force is the third intermolecular force, and it is a weak intermolecular force between atom and molecule. It exists between all atoms and molecule. With dispersion forces, the electron moves constantly. Thus, at any point, one side is more likely to have more electrons. This creates a temporary dipole. Without dispersive forces, all nonpolar molecules will be gases. So therefore, nonpolar molecules have dispersive forces. Dispersive forces can also be called van der Waals forces or London dispersive forces. Dispersive forces, the bigger the molecule, the stronger the dispersive forces. Why do you ask? The reason is that the electron clouds are bigger, so therefore the temporal dipole forces are also bigger. Thus, the bigger the atoms or molecule usually have a higher melting and boiling point. What trend do we see? We see that as we move across a period, the melting point and the boiling point get higher as atomic mass increases. As you move down a group, the melting point and the boiling point get higher as the atomic mass increases. This is also true for compounds. So HBr has a higher boiling point than HCl because Br is bigger than Cl.